Hello everyone, I am Sudarshan, Assistant Professor, Department of Biomedical Engineering from Sri Shanmuga College of Physics Engineering and Technology. So let us move to the next topic, which is communication protocols in IoT. Okay. So why do we need communication protocol? What are protocols and why it is necessary for an IoT? So initially in IoT, devices will communicate with each other without human interference, meaning each device will communicate to another device. Let's just say, for an example, a sensor will collect data. It will send all those data to your microcontroller. Microcontroller, if it is programmed to send all the data to your microprocessor, it will send all the data to your processor. Or if you have programmed it to send all the data to the cloud, it will automatically send all the data to the cloud. And then what happens? It will so once all the data is sent to the cloud, it will process on its own. So once the data has been processed, if it has been instructed to send a feedback to the real-time sensors or an alert system, then it will do so. So you need to have a set of rules so that each communication devices communicates with the other properly. Okay, basically you need protocols for one of the important. You have communication protocols so that there is no network lag behind. Okay, in real-time applications you will be having a lot of network issues, so that the working of your IoT happens properly. So now it will be, now we are going to see what are all the types of protocols we are going to use in IoT, which is MQTT, message queuing telemetry transport, CoAP, constrained application protocol. Next is hypertext transfer protocol. Next is advanced message queuing protocol, so data distribution service. Next is long range wide area network, LoRa WAN. Next is narrowband IoT. Now first we will look at MQTT. So let's look at MQTT. So MQTT is message queuing telemetry transport. So MQTT will be employed where you have a lot of latency and a restricted bandwidth. Let's just say you have a sensor in a remote area where you have a lot of communication disturbances, a lot of communication issues. So but you need to retrieve some data from the remote end, therefore you will use MQTT protocol. So what is MQTT protocol? MQTT protocol is actually a subscriber and a publisher protocol, which means initially what happens is all the publisher will publish a data to a common model, which is called as broker. So my sensor will collect all the data, okay, and it will send all the data to my cloud. Okay, here my cloud acts as a broker between a user and a publisher, which means between me and my sensor. So my sensor will collect data, okay, in real time. It will send all the data to a cloud server, okay, which acts as my broker. And if I want all the data from the cloud, I will get it from the cloud. So meaning a client and a publisher will never be in direct connection, which means I will not be able to get data from my sensor directly. My sensor will send all my data to the cloud. I will get all the data from the cloud. So here you have a real-time example, which is a smart home monitoring system. So you have a temperature sensor in your house. Okay. So what happens? That sensor will send all the data to a cloud server. Okay. Let's just say you are in a remote end, but you want to monitor what's the temperature in your house from a remote place. So what you do, you log into your application. You will see what are all the temperature changes which has happened throughout the day in your house. Okay, so this can be employed where remote monitoring system, where you have some smart homes. Okay, so basically data collection happens. The collected data will be sent to a server. If you need the data, you can contact the server and then get all the data from your cloud. Okay, you cannot get contact to your sensor directly. This is how MQTT works. So why do you use it? If you are using some home monitoring system, then you don't have to look at data continuously. So whenever you want some data, you can fetch it. So by using this, you can limit the amount of bandwidth. So whenever your signal is strong, it will be sending all the data to your cloud. So whenever you want, you can look at it. Okay. So HTTP, which means Hypertext Transfer Protocol. So here you have a client server architecture, which means a client will request something to send to a server, and then once your server receives those requests, it will agree to it. Once the service request has gone through, it will send all the data to the cloud. And then what happens? If you want some data, you will request some data, and then you can get those data. Okay, it is completely based upon request. I will explain to you based on a example. Okay, here each request is independent, meaning once a request has processed, okay, the previous request will be forgotten by your system. Okay, so we will take the previous example. You have a smart temperature monitoring system. Okay, so you have a sensor which monitors temperature at your home. Okay, so now you want to look at the temperature at your house. So what you do is you send a service request to the cloud. Okay, so which means get data of my house. You have sent a request. Then what happens is the cloud will push that request to your sensor. So now the sensor will record the data, okay, and then push that data to the server, post that data to the server. Okay, once that has happened, you will again receive the data which has been sent now. Okay, and then your update ends. So you will first request for some data. So it goes and prompts your data collector. The data collector will collect the data. Okay, it will send a request. I have collected this data. Now I am publishing it. And then what happens? Your server will send it to you. So whenever you want your data, you can request it and then get those data at the required time, not continuously. So by using this protocol, you can save a lot of memory space. Okay, whenever there is a need of some data, you can request it and then get it. Okay, so these applications can be used in multiple areas. Wherever you need a data at live, you will use this protocol. Okay, so next is, so now we are going to look at constrained application protocol. So here you have a lot of data constraints. Okay, this is used where you have very low resources and very low network area. Okay, so where you have low power devices, you can use CoAP. So this is also a service request based application or protocol. I will give you a real-time example. Now we are going to look at a smart irrigation system. Okay, so in irrigation system you have installed a moisture sensor, you have a motor. So based upon the moisture sensor value, your motor can be turned on or turned off. Okay, but while using this protocol, it will not turn on automatically. You have the control to turn on your sensor from a remote end. So now how you use CoAP? Initially what you do is you will request for a moisture value. Okay, so your sensor will, so if you want your moisture value, you will prompt a request. The sensor will send you your moisture value currently is 60%. So what you do? You will again send a control request where you can turn on your pump. So you are sending a request to turn on your pump. So it will turn on your pump. Water flows into your field. After some time, you will request for data again. It will send the current moisture value and then you will turn off your pump. So this is how your constrained application protocol works. So we will look at the rest of it in the next topic. So we will look at the rest of it in the next topic. Thank you.